this video, we're going to talk about the multiplicity rule, upper bound and lower bound. I will be showing you 6 examples, and these examples are only few of the possible equations or problems you may encounter when solving polynomial functions. Before we go on to solve the equations, we must know why we should learn about this rule. 1. Recall the previous concepts in solving polynomial functions. 2. Apply the concepts learned to help narrow down the number of choices in finding the zeros of the given polynomials. And lastly, 3. To be able to answer the problems confidently. Before we proceed with the tutorial, we must know that the multiplicity rule, upper bound and lower bound, is not a formula to solve a polynomial equation. However, it is a way to narrow down the number of choices. It is somewhat a technique to shorten the process. The first problem is asking us to find the roots of the polynomial p of x is equal to x minus 3 squared, x equals 2 cubed, x plus 1. To solve this problem, we can either use the FOIL method to multiply x minus 3 squared times x plus 2 cubed times x plus 1, or do this instead. As you can see from the given, we are given the x values that would satisfy this equation, and basically the solutions to this equation. What we need to realize is that we have 3 things that are being multiplied, but then they're equal to 0. So that means we can apply the zero product property. Zero product property basically equals every x values to 0. And that means we get the value of the x. So we get x is equal to 3, x is equal to 1, and x is equal to 4. Remember that degrees are basically the multiplicities. So we get 3 multiplicity of 2, 1 multiplicity of 3, and 4. Remember that the multiplicities are basically the degree of the x values. For the second type of problem you may encounter when looking for the zeros of a polynomial function, we are asked if negative 3 is a lower bound of 2x to the 4th minus 9x to the 3rd plus 7x squared plus 9x minus 9. To solve this problem, we should use synthetic division. But before doing that, we should first look for the factors of the constant and the leading coefficient. So L over F. However, this is what we normally do if we are not given a number to divide the polynomial with. So for this problem, for the synthetic division, we are given negative 3. So we put that outside. So note that these numbers, the 2, negative 9, 7, 9, and negative 9, they are coming from the polynomial given. They are the coefficients of the polynomial given. Based from the answers yielded from the polynomial we divided, we can see that negative 3 is not a root of the polynomial given. However, its quotient did produce a pattern, an alternating pattern. It goes from positive to negative, then it goes back to positive, and so on. So, according to the multiplicity rule, lower bound and upper bound theorem, it states that if the polynomial divided yielded a quotient that has an alternating pattern, then that means it's a lower bound of that polynomial. If a possible root is a lower bound of that polynomial, then that means that there will be roots lower than the possible root that you divided the polynomial with. So there would be no roots lower than -3. So the statement given is correct. -3 is a lower bound of the polynomial 2x to the fourth minus 9x to the third plus 7x squared plus 9x minus 9. So for the last problem, we are asked to form a polynomial out of its roots. So basically, we can just multiply all the values using FOIL method. So just a reminder about the multiplicities. For example, you have x minus 1 multiplicity of 3. Then that means you will need to write x minus 1 3 times. So the final answer is x raised to 5 minus x raised to 4 minus 9x raised to 3 minus 11x raised to 2 minus 4x is equal to 0. Remember that the equal to 0 is important because we are looking for an equation. Multiplicity rule is only a technique, so it is still important to know the basic concepts. Practice is a vital part and it will make reviewing more effective. There are much more techniques and tricks to learn in the future. But for now, I am Sofia Magno and this is Multiplicity Rule, Upper Bound and Lower Bound Theorem.